Okay. Yeah, there's a little bit of delay on my end, so as I transition, give me a minute. Yeah, see this okay? All right, so
Yes.
the main thing I want you to know in this section here, as a function, just looking at a graph and you figure out the domain range. Do you know what type of function? And I'll send you a sheet if I haven't already. I need to double check. A list of all the parent functions. So just a visual of what does a parabola look like? What does a cubic look like? What does a square root look like? You don't have to memorize that, but I would just have that aside. Make sure you have the parent functions with you. Okay. So if you look at number 5, the domain is going to be the x. So we check out what is the smallest x here. What is the highest x? This function is finite. It stops and begins here and there. If it's open, then we should understand that we cannot include it. That is considered to be an open parentheses for interval notation. Okay. So this means you're starting right after -2. So -1, -2. Like so, -2.001 is cool, but not -2. On this one, it's a solid dot. So it goes all the way up until 2, stops right at 2, not before 2. That's the difference between parentheses and brackets. Okay. Now, range is just the up and down, like how high did it go on the y? How low did it go? So the lowest point on the y is -5, and it actually is closed there. There's no hole. So you put a bracket. It goes all the way up until 4 on this section. Over here it's open, but here it's not. So you can include this point here. It's just -5 to 4. Nothing crazy, right? Now if you scroll down here, here it is. And again, we talked about this already, the functional notation. Right? This means I'm plugging in the x, right? This is the x input, x input, x input. So whatever's inside the parentheses is what's going inside the function. The output that they're asking for is the range, the y values. The output values are part of the range. So if you were to have all the x's, just to go over what we talked about already. We have a -1 first, right? We have a 0. We have a 1. We have a 2. All the y values, at least here in this section, not all of them, right? We're just looking at these few points. That's going to be this solution, -5, -4, -5, 4. Now, they're all coming from the graph. If you look at your graph right here, -1, right? That is talking about this value here. So what is the y value at -1? So it's really this point that they're asking about. So the answer would be -1. We have an output of -5. Okay. So these two are connected as a coordinate, as an ordered pair. So input, output, x and y, ordered pair. Visually, it is a point on the graph. The graph is actually a function. But it's all connected, it's all the same thing. Is there any questions? We're rehashing everything we've talked about already. Is there any questions on those concepts?
Can I ask something about the increasing and decreasing stuff?
Yeah, we'll get to that in a little bit.
Okay.
Soon. But as far as this current concept is, it's okay. Yeah, I think the increasing is coming up.
I had a question.
Mhm.
The way you wrote the X and Y examples, is that kind of the way you want us to write it in terms of the test? Since we're using the graph and there's really not any algebra that we're doing?
For here, I'd be fine if you just, if there's nothing to do here, so you're just gonna look at the graph and write the answers. So if you wrote it just like they did here, it's totally fine.
Okay.
Okay. I'm just trying to show you how it's all the same as what we talked about before. Right. X values are inside right here. Y values are what, yeah, function outputs. And if your function is graphed, then you can look at the graph and find those specific points, right? Then you give us an actual equation, so we have to use the graph here. Okay. Oh, it's the same type of deal here. All right. This is a piecewise function. I think we talked about that a little bit, right? Excuse me. So there's one function dictating this piece, right? And then there's another one dictating this. They're both lines. So really you have an F, even though that we don't have to do this part, just so you remember. Right. This piece, we don't know what it is. Just gonna put quotes here. We could figure it out if we wanted to, but not do more work for no reason. This would be less than or equal to 1, right? So this first line is happening at less than or equal to 1. The other line, line 2, we could call it if you want, starts when X is greater than 1. That's when this one begins. Do you guys remember when we talked about that? We have two different equations. The equation in here would be graphing this line here. So we can call this L1, right? This is like my first piece.
We've done just like the union thing.
Yeah, you're basically combining two functions together. Yeah, there. Any question on the piecewise? You guys remember this? They didn't ask anything about piecewise, but that's how this graph, that's where the graph comes from. So I'm just reminding you from a week ago.
Like you cannot say like from negative infinity to 1 and then union with 1 to infinity.
The domain would be everything because it covers every single point. If there was like a point not covered, then you would have to use unions to exclude that point. But here, notice I'm including 1, and then right after 1, I start over here, right? Before 1, I'm touching all the x's. So every single x is being mapped onto some y all over the place. So no x was missing. So technically, all we got to do for domain is negative infinity to infinity because we can see it. None of them were skipped, right? We're assuming that this goes on forever.
Is it okay to still put 2 answers for that?
How would you put 2 answers?
So you'll do the first line, which I got parentheses negative infinity with a bracket 1 and then a open parentheses 1 to infinity.
I mean, that's not wrong, but it's the same thing. Because you're
Okay.
including the same point twice, right? You're saying,
Yeah, pretty much.
right, you're saying this 1. Then you're including 1 again. So we usually do this type of union stuff if we need to exclude something or there's a hole we got to skip over. But since 1 is cool, right, we don't have to do that. We can just say everything before and after 1. There's no reason to be, trying to avoid the number 1.
Okay.
But yeah, I guess I would say this is not wrong, but redundant.
Yeah.
Okay, as far as range though, right? You notice there's a lower bound here. It shoots upward forever, but it doesn't go down forever. Right, this line keeps going upward, this line keeps going upward, but it doesn't go down forever. The lowest point is right here, even though we don't include it because it's open. So you have to put that parentheses at -4 because there's a hole there. There's an open circle. And since it shoots up upward in both directions, like, yeah, I'm going to cover all the y's eventually. Does that make sense? And when you're doing range, you're looking at the y values. When you're doing domain, you're just looking at the x's. The same stuff we've done before. Do you guys have any issues with these problems? Okay. So not too bad, I hope. I'm assuming it's pretty clear, right? Let's move on to something else then. After that, they start talking about the determine whether or not the graph is a function, which we already talked about, I believe. We said that if you graph a vertical line at any given spot, it should only touch the graph one time. Here, I'm going to hit 2 spots with any vertical line that I draw. So because of that, it is not a function. Right, that violates the definition we talked about. We said that every input, right, should only have one output. But this number you can see right there, number 6 is going to 2 different spots. So that's a problem. Does that make sense? So like, it's like the phone number problem, right? This person has 2 phone numbers. Doesn't make sense. Right? It goes to here and to here. So all you got to do is just draw vertical lines through it. This one is obviously a function. I'm never going to hit more than one time. No big deal, right? Any questions on 9 and 10? Does that make sense? Do you see why or why not like these graphs are functions?
Yeah, it makes sense.
And the circle is like the famous one. Circles are not functions. They are relations. This one is a function, but right at the center, it looks like there might be a problem, right? But there's an asymptote here that stops this function from crossing over. So it gets infinitely close, but never actually touches this vertical line here, the 0 point. Right in the center, it's never gonna pass it. So since that's not the issue, we can see if I graph vertical lines anywhere, I'm only gonna hit it once. So it has to be a function. So all you gotta do is look at it and graph it, okay? Any questions on the vertical line test, which we've already discussed a little bit? And that's
No.
easy. Oh, go ahead, sorry.
Oh, no, I was just saying it makes sense.
Okay.
Oh, when do we see the horizontal line test?
Horizontal would be if you want to do 1-to-1. If you want to tell if a function is 1-to-1, then you can do a horizontal line. So if it is a function and you want to learn if it's a 1-to-1 function, then you can draw vertical lines. But that only comes up when you start to discuss inverse functions.
Okay,
which
I'm
will-
like, what
little
class
later.
is that?
That's this class in a few sections.
Okay,
We'll talk about the inverses. Okay. Oh, on this, I think in this chapter or the next, you're going to see a lot of finding zeros. So me pull out a graph here. Just in case you forgot what a zero is. So let's say we had, I don't know. Let's make up a function here. Yeah, that's fine. Okay. So when in the book and in the notes and in the videos I hope you watched or read, when they talk about zeros, what they're talking about is the location when it crosses the x-axis or it touches it. So location of a 0, 0 or -1, 0. So these, whenever you have a y value that is 0, whenever you have your graph cross the x-axis or the origin, of course, that's still the x-axis. But if it touches it or crosses it, or if the y's are 0, it's all the same thing. We call those zeros of the function. Okay, that's what they're asking about over here. Is it find the zeros? So you could graph this and just look at it, right? Let's just do that just for the hell of it. Graphing is the easiest way to do it, but that's not what they're asking us to do. I just want you to see that. 2x squared minus 11x minus 6. All right, let's see where they're at. So you can see them right here, right? The solutions. So when you solve this by hand and algebraically, the x's that we solve for when x equals whatever is going to be these two numbers, the 6 and the -0.5. So visually we're solving for the x values of the function when your function is 0. Okay. And those become really useful in applied problems, right? But right now we're just doing theoretical stuff. So if we go to this question, do it algebraically. So they don't want us to graph it, even though we knew the answer. It's right there, and we saw in the graph. Let's go ahead and solve it by hand. 13 and 14, same stuff. We'll do both. This was section 2.3. And remember, always assume that whatever we haven't talked about will be extended, okay? Don't freak out about those due dates. The rule of thumb is bare minimum, finish whatever we talked about. If you're doing that, then you're good. If you're ahead of me, then that's even better. Okay. Give me a second. Computer freezing on me again. I came to use the computer at school thinking it'd be better, but it is not. Okay. Find the zeros. Algebraically. Oops, spelled that all weird. I wrote it all weird. So whenever they say find the zeros, that's they're asking you to find, well, that what will make this function equal to 0. So simply set this to 0 and solve, and you'll be done. So subtract 24 over, or move it over, and whenever you cross the equals, you just switch the sign. Divide by 3. both sides, and we have x equal to negative, what is that? Does it go in evenly?
8, I guess.
What's that?
8.
-8.
Yeah, 8. So when x is -8, the function will be 0. That's what we're doing. That's what, when you set something to 0, that's what's happening. So you have a point at -8 comma 0. This is the 0 of the function, okay? This x value makes it 0. Does that make sense when they ask you that? Fourteen. That was problem 13. No, 14. This was 13. Question was 2x squared minus 11x minus 6. So same deal. They want a 0, so set this equal to 0. Now, at this point, whenever you solve a quadratic, whenever it's set to 0, you have to factor. So you can do AC method or trial and error, or if you really want to, you can do quadratic formula. But like I said before, that's the hardest way. So if you remember our AC, that's one I would like to use. A times gives me -12, and then you look at these factors and see which one adds up to the middle term. Okay, so we got 2 and -6, -2 and 6. We got -4 and 3, right? 4, -3. All right, what else we got here?
-12 and -1.
Yeah, I think that's gonna be the one we want, right? One of these. On the right hand side, you just add this. You add these up. You add the factors. So 2 plus a -6, -2 plus 6. Just keep going downward. So we're going to use these factors because it adds up to -11. So essentially, you force a grouping scenario. So -11 is going to be broken up into these two pieces. So -12x minus 1x minus 6. So these came from here. So this is just being broken up into plus. Right. So just refreshing you on the AC method. If you want to use a different method, that's fine. I don't care how you do it. As long as it's legit math, it's all good. But this method works by factoring a GCF of the first two terms and then the last two terms. They have a 2x in common, so factor that out. And then you look at this and you factor whatever they have in common, which is nothing other than a 1. All they have is a 1 in common, so factor on the next step, factor what these two have in common. And we're left with this. So at that point, we are going to put arrows here. Too many equal signs. So So at that point, you just set it equal to 0 and you solve. And those are the numbers that we saw on the graph, right? When we graphed it. So this is what they want you to do algebraically. But I need you to see what that meant first, visually. Any questions on any of these steps here?
On the test, do you want us to show that kind of work?
Yeah, you're gonna have to factor. I mean, and you can use any technique you want, but just make sure you show your factoring and your algebra.
Okay.
Okay, let's see if I can. This thing will let me. Switch back over. Finally. And yeah, these are the values we found. So when it's 6 equals 0,
You're kind of breaking up.
can you hear me? Can you hear me okay?
I can hear you now, but you were breaking up earlier.
Oh, okay. Yeah, I'm having some issues, but sorry about that. So we set the function to 0. And we got the x values. So that's why the functional value or the y value is 0 here. Okay, that's all they want you to do. For 15, the denominator is never going to make, is never going to make the function 0. So all you got to do is look at what's happening at the top. For these types of functions, just set the top to 0. Don't worry about the bottom. So when you solve it, you can see, right? It's going to be this. Same thing here. All you're going to do is set the top part equal to 0 and then factor like we did. This one will be easier to factor, so you don't really have to do AC for that one. You should see that if I set this to 0, right? You can do the trial and error super easy. Right, just make sure you write your parentheses like this, right? Trial and error. Then you look at the factors of 28 that will give you -11. So they're both going to have to be negative. -7 and 4, right? Multiply these together, you get 28, add them together, you get -11. So all you have to do is look at the top part. Anyway, any questions so far on finding zeros? Right, let's move on to increasing, decreasing. So 19, I think the last few questions are just about increasing and decreasing. So I think the easiest way to think about this. So look at number 19 here. So whenever you go left to right, just picture like a little car driving down here, right? If it's driving down this hill, the headlights would be pointing down, right? It's going down the line. Headlights are downward. So if the headlights are down, then it's negative. When it gets to the flat road though, right in the center, it's going to be constant. It's no longer negative. Then again, starts to decrease. Goes down here, headlights would be going down. You just picture a little car going from left all the way down here. Does that make sense? So all you have to do is figure out the X values of where that's happening. So we can see that there's a change right there. So before this point, I'm decreasing from -infinity all the way up until this spot. Okay, decreasing. And then right afterward, I'm decreasing again. So technically, over the entire function, I'm decreasing. Although I would disagree that there is a point where it's constant, right in the center. Let me zoom in there. But I think those ideas are more calculus ideas, but they're kind of ignoring this center point. But since it never really changed, we can say that it is decreasing the entire function.
Oh, I have a question.
Mhm.
So why do we use the X values?
It's always the X, because that's we're looking at the domain basically, like where is the function decreasing? When we say decreasing and increasing, we're looking at the Y values. But what's creating those values? Well, the X values create them. Right.
Okay.
So because the Y is the dependent variable. So that's what we look at. What's causing the decreasing? Well, the X values everywhere. They dictate what the function is doing. Okay, so look at this guy here. This is a more interesting problem. So over here, I'm driving my little car, right? Decreasing, decreasing, and then suddenly right here, constant. And then right after, my car's pointing upward, increasing. So visually, we should say that it's increasing from this X value here until infinity, because it keeps going upward forever.
And I have another question.
Sure.
So, well, why do we use the like in the parentheses instead of the bracket if it has a point and the point is filled?
Yeah, that's what I was talking about earlier. This location right here, the function is constant. It's not increasing or decreasing. We're increasing right after. We're decreasing right before. But right there, it's neither. It is constant. So we have after 2 till infinity, we are increasing. But at 2, we are not increasing. Before 2, going all the way to the left, the car would be coming downward. After 2, I start to go upward. So there's a point that we call an inflection point. That's when the concavity changes or the slopes change, but as we go more into detail in Cal 1 about that stuff. But do you see how this point is neither, right? That's why we have to put parentheses. Is there any question on these concepts? Do you see where we're increasing and decreasing by looking at this graph?
Yes.
Yes.
Okay. Let me know. So if you have a location where the function is just like straight like this, that is going to be a location of constant slopes. So the function would be constant here. But technically these points would be constant, but since they're asking about intervals, that's why they say it does not exist. Because they're single points. They want actual intervals. If you look at the question, right? They said determine the open intervals where it's increasing, decreasing, or constant. We do not have an interval where we're constant. We have two single points. That's why it said does not exist. So even though we said there is a constant right at 2, it's not an interval. Looking at this graph, do you see where we are increasing?
The 2 times from the negative infinity till the 1, I guess, till the 0. Yeah.
Yeah, it's all the way to this location, right? Then you want to see the other part. See how we're going, the car's going up here, and then starts going down, and starts going up again, right?
And the 2 to the infinity.
Yeah, it's gonna be 2 to infinity. So this would be where we are increasing. And we're only decreasing in this location right here. In between here. Are there any questions about how we know visually where we are increasing or decreasing?
So these are all going to be X values, right?
Always going to be X values. If they ask about increasing, decreasing, constant, or anything like that, you're looking at the domain values, the X values.
Okay, thank you.
Here you can see there's a constant spot, right? An actual interval. Okay. Anyway, that's pretty much the main idea here. Last thing here, there's one last small thing. Average rate of change. So here it's just a formula. It's actually the slope formula in functional notation. It's all it is. Let's do number 25. All right, average rate of change with a function from x1 to x2. And they give us a function of x squared minus 4x plus 7. And they say that x1 is the 1 and x2 is the 6. Okay. All right, so all you're doing is this. So the average rate of change is just this formula. Is this here. So f of x2 minus f of x1 divided by x2 minus x1. So this is pretty much the same thing as y2 minus y1 over x2 minus x1. The only difference is we're using functional notation and we're applying the slope formula to any function, not just a line or a linear function. Okay. So it helps to find these values first before we do anything. So f of x2 means plug in x2 into the function, right? That means plug in 6. Let's see what you get. So that'll be 36 minus 24. That would be 8, right? Plus 7. Okay. Now do f of x1. That will be 1. Oops, let me show that an in-between step, forgot. That'll be f of 1, which is 1 squared minus 4 times 1 plus 7. Was it 12? Excuse me. Tired. Yeah, it is. I bet. I don't like numbers, man. Just double check me all the time. Okay, so 1 squared, 1 and 7 will be 1 minus 4 plus 7. Okay, so that should be 4, right? Okay. So at that point, we're just going to plug them in here. And it will be good. So average rate is equal to, I'm gonna write the formula one more time, just to be proper. So that will be 19 minus 4 over 6 minus 1. So that will be 15 over 5, which is 3. No. Yeah. This is the average rate of change. So that's how you find it, but what does it mean, right? Like the work itself is just a formula, but let's look at a graph and see what's going on. We have x squared minus 4x plus 7. And they have 2 points of interest. They gave us an x value of 1, and then we plugged in the 1 and we got 4, right? And then they gave us another x value of 6. We plugged it in and we found 19, I believe. All right. So here are the 2 points. So what we did. So basically, if you connect a line to these 2 points and you found the slope of this line here, the slope of this guy is equal to 3. That's what we found. So the average rate of the function is the slope of the line connecting 2 points. Okay. Does that make sense? Do you see what it does? This becomes really important in calculus. When we start using limits, we start to figure out the slopes at any given point, instantaneous rates of change. Or if the function represents like velocity or something, these slopes would be acceleration. Or if they're forces, then the slopes will be different things. But anyway. But all you have to do is use a formula, plug in the x1 and x1 and x2, find your functional values, and just plug them into the formula. That's it. You get a number. Just remember what that number means.
So you're saying that that number 3 is representing the rate of change?
Yeah, number 3 is the rate of change, which is the same as the slope that connects the slope of the line that connects with these 2 points, the 1 and the 6, on the function. Okay, so that's pretty much it for 2.3. Any other questions? Does it seem doable? Parent functions, I might skip this guy here. Let me look at it first. So for this, you need a list of the parent functions. So it starts off just, do you know the names of them? And that's nothing we shouldn't worry about that. I'll let you do that. Over here, they want us to start sketching the values. Let's see here. Someone was asking that they couldn't find this open circle function. I don't remember who that was, but do you guys have any issues with graphing here? On this
That was
section?
me. I couldn't find the open circle.
You couldn't find it? Let's see if I can, well, let me do this. I can mess with it.
Yeah, I kept hitting the double arrow and then the solid circle, but I could never find the open circle.
Yeah, let me see if I can get to that question. So we can figure it out together real quick. It's 2.5, right? No, 4. 2.4. I go this way. No, that's the video.
You have to go down a little more. It's in the homework right there. Go up a little bit. Right there.
Oh, here it is. I was like, what the hell? Usually it's right after. There you go. That's throwing me off. Please let me answer the question. This one. Okay, so it's letting me do it. Layers. This is a circle function. That's just a point. Okay, so for this question, we know it's going to be open at -2 when I plug in -2 here. If I plug in -2 there, that would be -1 minus 4 is my -5. -2, -5 would be here. But it needs to be open. So right there. Function graph layers. Random points over here. Oh, here it is. You gotta click it in graph layers. So once you selected 2 points, you go in here to choose it.
Did your screen freeze up?
No, oh, hold on. Maybe, oh, you know what? Shit, it jumped to a pop-up. Let me switch over. I didn't realize you couldn't see that. Can you see this?
Yes, I can see that.
Yeah.
Okay, so let me redo it. So if you're doing it piecewise, right? It's gonna have
Yeah, I'm following you.
a point, well, a solid point or an open point. So let's just pretend it's right there. And then I click over here. So once before you finish, you go into graph layers. You put open,
Okay, I see that.
and it should take care of it. But anyway, let me go back. Okay. Yeah, I want to show you the parent function. So I'm going to send you something like this either tomorrow or later today. I'm going to find it in my files, but it looks something like this. So it says here the x function. Let me zoom in a bit. The parent, meaning the original x, is going to be this linear line that goes through the middle. The quadratic is going to be just the x squared, basic parabola, cubic has this shape, and etc. So if you add +2 or if you have a 2x squared, those are all just transformations of the parents. They're just shifting, stretching, moving, shrinking these basic functions. So let's say just have this either print out or draw them out on a formula sheet, just so you have them. These bottom, I mean, I'm going to send you the main one. These are from pre-cal, so don't worry about that for now. But you should know what they look like. So if someone tells you square root x, you should think this shape. if you see a parabola, if you see any quadratic, you should think it's some type of parabola. If you see a cubic, it should have some kind of like weird S shape. Okay. That should all be in the back of your head. That's all I really want from you from this section, but let's look at it carefully. So this section basically is gonna test you, can you plot points, connect dots? Can you plot this kind of graph? It's a piecewise type, which we've already done together. Just make sure you know where to put the open, right? This line has the open part, this one has a closed part. For number 11, I would advise you doing these by hand, because on the exam, when I have you graph them out, or at least do a sketch. I'm not gonna have multiple choice, right? That's not what's gonna happen. So I'm gonna give you a equation like this and just tell you graph it. Just do your best. Okay. So what matters is just graphing around this point here. All right. But if you know what the parent looks like, all you have to do is adjust. Okay. So if you have a parabola, +1 means you're just going to shift upward. So if you look at your graph here, this is the normal parabola over here. It looks like this. So in this particular homework, we got to find that piece, but they cut it off after 0, so it doesn't have both shapes. So for this homework, you can just cross out things that don't make sense. Like notice how this is open right here. So this is wrong because it's not supposed to be open. It has an equal to. Right. This one's wrong because the parabola is facing downward. This is a positive parabola. If there's a minus in front of the x squared, then yeah, it's going to be mirrored or reflected. Okay. Now, this guy is facing the correct direction and it's filled, so that's going to be the one we care about. So you can rule everything out pretty quickly just by looking at the graphs. Okay.
Sir, I think Nathaniel has a question in the chat.
Yeah, I think they've already been open. As I said before, if we haven't talked about it, it's going to be extended. I think it closed like a couple of days ago or something.
Yeah, he's talking about like 2.4.
Yeah.
He says he couldn't access it.
Yeah, it's been adjusted. If not, it will be. Let's see, it's September. Yeah, I'll adjust it soon. If it's not already. Let's see if I can do it right here, maybe. Wait. The computer's being weird, so I'll adjust it soon. It's not letting me multitask. But yeah, I'm not really going to test you too much on 2.4, but I will allow you to have the parent functions. Just know how to recognize those. You should be okay. Okay. Make sure you know how to plot points, of course. We've talked about piecewise already. So there's not much new things here. The only difference is that they're connecting different types of functions together, not just lines. That's it. Yeah, I need to just. Maybe I go back here, it'd be better.
Hey, sir, on the test or before the test, will we have a review or
Yeah,
a
we will.
worksheet or something?
Yeah, we'll review together. We will. Let me fix this real quick. I thought I had changed it, but I guess I didn't. Okay. You guys have any questions on 2-4? Is that pretty clear?
Yes.
So all I want from 2-4 is you recognize the parent functions, which I'll give you a list of them soon. Let's see where we're at on the schedule. Okay. Yeah, we'll stop here. We'll do 2-5-3-1 on Thursday. Do you guys have any homework questions or any issues you're having? Or any concerns?
I wanted to see if you can upload the video for 2.2 functions. I don't need you to open the homework, but I'm having issues with my math. I don't think I'm doing something right when it comes to the, oh, is that formula called the difference quotient formula?
Oh, yeah. Let me see.
I just want to reference your video and see if I'm doing something wrong with my algebra. Because I feel
Yeah,
like I'm
it's-
doing it right, but I keep getting the answers wrong on 35 and 36.
Okay, let me see. I sent it on remind, but I can send it again. Can we see a second? So 2.2 you said?
Yes.
Now give me a second. Yeah, it didn't send it. Yeah, you're right. I don't have it up there. I'll upload it soon. It's not in. It's on my computer, and I'll send that to you. I can also send you a video if you like from somewhere else too. For now, if you want it to right this second.
It doesn't matter. I can wait for it. That's fine.
Okay, I'll
Thank
send
you.
it to you either tomorrow or later tonight. Send a message on remind so I don't forget. That way I have a place to send it to you. Let me fix these homeworks. So we talked about 2.3. Let me make sure that it's allows you to do one by one. Before I forget. You guys have any other questions? there anything you're struggling with or is not working for you? Okay,
Yeah, I have a question.
yes.
Will we be able to use a graphing calculator on the test?
Yeah, I don't mind if you use one, but you should try to do by hand as well, because not every instructor is gonna let you. So make sure you're able to do it both ways.
Okay, thank you.
Because I think in Cal 1 or Cal 2, they might be strict about it. So you can check your work, no problem. I don't mind. Just keep that in mind.
Thank you.
Oh, you haven't about an hour left, so please use that time if you can to do that extra credit. Just get out of the way. Okay, it's a lot of points if you think about it. Because it's applied to the very final grade, the overall grade. Yeah, if you have no other questions, you're welcome to head out. I'll stick around for a bit.